TB. That is mathematics.
Yes.
Okay. Today we are going to do some a question which we were supposed to do on that day, which I gave you as homework. Do you all see it? Do you see the homework which I gave you? Remember, I'm sharing the screen. I may not see you. Let me do this. Let me see. Okay, I think it's fine. Better. Okay, yes. This is what we are to do today, but not the entire thing until break. Then after break, then we'll do the interaction. But for now, I want us to do this homework so that we may perform the pairwise comparison of the assembly times. Ladies and gentlemen, you did this this homework. You did this homework. Let's talk, ladies and gentlemen. Let's talk. Yes, then let's start now. Now, looking at this homework, I just want to explain certain things. People were asking me what is the treatment from all these questions. Then these are the definitions of the treatment. Treatment is a factor whose effects are to be investigated. It means which factor is to be investigated. Looking at this, let's read this. A production manager wants to see if 3 assembly methods have different mean assembly times. 5 employees were selected at random and assigned to use assembly method. Now, what do you think from here? What do you think from here? What is your treatment from this statement? When you read this statement, what is your treatment? Ladies and gentlemen, do you hear me? Are you able to hear me? Are you there, ladies and gentlemen?
Yeah, we hear you, sir.
Yes, we can hear you, sir.
Oh, yes. I want to know what is your treatment from, what is your treatment and also your blocks from that statement. From this statement, it says 5 employees were selected at random and assigned to use each assembly method. A production manager wants to see if 3 assembly methods have different mean times, assembly times. What do you think is your treatment? A treatment is a factor whose effects are to be investigated. Listen to this man. This man wants to investigate the assembly methods. He wants to investigate the assembly methods. Whether they have different mean times. This one. That means from here, Yij will be the main assembly time, assembly times, and these are in minutes, meaning the value, let's say here is methods, here is employees. The values that are here, the values, let me do this. This is A, this is B, this is C. The values that are here is the assembly times. That means these are minutes. This is the YI, the YIJ, the values which are here. Do you understand, ladies and gentlemen?
Yes, sir.
Then it means if you write this, it's going to be plus, this is the mean, this is the treatment, plus the blocks, plus the errors. Now, this one we have, which is the assembly time. It's in minutes. Now, what I want from you is to give me the treatment and also the blocks. Now, in the selection of a treatment, it is important to define clearly each treatment and to understand the role that each treatment will play in reaching the objective of a treatment, of experiment. Because we want the experiment is to find the time, the assembly time. The objectives, then let's come here. An experimental unit. What is the experimental unit from this example? What is the experimental unit? Okay, people are answering, are saying treatment is employers, treatment is assembly method. Okay. Now, what do you think is the experimental unit? What are they using? What are they using to so that we can get? You remember the example of students and methods. We said we have students, or let me just explain this. Let me explain this. CRD, we had the students here, and under students, what we did was to choose students for different methods. Method one, let's say method one of teaching, method two. And this students was experimental unit. And this was treatment. Do you see? We choose students randomly. We choose a student here at random to assign the student to what? To method of teaching. Remember, the method was online, and the other one was face-to-face. The other one was self-study. Then when we come to a randomized block design, this is student. Now there is a block. We can block it with what? With gender. Where here is male and here is what? Female. That means these two, they are playing a factor. They're having a factor. I'll explain factor to what. Then male, under male, we can have three different methods. Method one of teaching, method two, method three. Similarly, also here we can We can have that. All this, they're contributing towards what? The pass rate. That was the IJ, the pass rate. We wanted to find the pass rate using experimental unit, which is student, to attend in these methods, which are experiment. Now, we blocked them, or we said there is another factor called gender. Gender is two, can be male or female. Now, I try to explain that so that we can answer this. Experimental units is employees. Yes, experimental units is employees. Do you all agree with Kulofelo? Do you all agree with Kulofelo? Yes, 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 yes. That's true. Experimental unit is employees. They use employees to do. Now, what is the treatment? What is the treatment? What is the treatment? Ladies and gentlemen. Oh yeah, methods. That's correct. That's correct. That's correct. Then remember, under experimental unit, we have those employees, employee 1, employee 2, 3, and 4, and 5. Now, let's go to our question. You said you solved this question. For those who did not solve it or they found it difficult to identify the treatment, and is here. 5 employees were selected to do what? To assign to use what? Each assembly method. It means these students, sorry, these employees were chosen to do what? For each what? Assembly method. Was selected assembly method. It's the same way as student assigned. Where is that? Where is that? It's the same as students assigned to each and every method. Each and every method. Let's go here. Let me go here to show you the other one. The student assigned each and every method. Then let's continue. This was supposed to be done. Now let's calculate. Since we know that methods are treatment and we know that employees are blocks, then let's solve. Let's solve, ladies and gentlemen. Let's solve. Let's perform what we call ANOVA. Any question, ladies and gentlemen? Any question? Kulofelo.
Sir,
Hello? Yes.
can you please go to the example? I want to copy the table.
Or take a picture. Do you have a phone with you? Take a picture.
Let me screenshot.
Yeah, screenshot. Yes.
Yeah, thank you.
Yes. Now, okay. Somebody a question. Malule, that's Malule.
Hello, sir.
Yes, yes.
Hello. Did you mention what the blocks are? I didn't hear that part.
Oh, we said under experimental unit is where we are having blocks. And experimental unit is employees. That means those are blocks, isn't it? Is it employees or employee? Let me verify. Employees or employee? Employee, yes. Employee. Now, let me write. Then blocks, sorry, what am I doing? Blocks. All right, employee. Then the other one is treatment. Is methods. Is it methods or method? Methods or assembly methods. Let me just say something on here. Please make sure that all the time you say let blocks. If you want to use blocks, the B. If you want to use SSB, SST for treatment, please just say let blocks be employee and let treatment be assembly method, so that you can use SSB and SST. But some were asking me if it's like this, can I say SS block is SS employee? And I say or I say blocks. Sorry, I say blocks when it comes to ANOVA. You remember ANOVA? ANOVA, you are having, this is the sources. Now, you are having treatment, you are having blocks, you are having error. Somebody was asking, can I say, because treatment I know is assembly, can I say assembly method? And blocks I say employees? Employee? Yes, that is correct. You can say that. Unless otherwise, if you don't want to use the assembly and employee, just say let blocks be employee and let treatment be methods. That is that. That is
See, did you get
yes.
the SSB there? Your handwriting.
Yeah. No, what I'm writing here is just a review of what you were supposed to do. I will write well. Don't worry. I will write well. I will write well. This was just to say, if you don't want to,
And and I feel like sometimes you are moving very fast. Can you please reduce Nyana? Just to let you know.
oh, who's talking?
It's my bunda.
Blessing.
Yes.
Mabu, you see Mabunda, ne? You Mabunda. Is that life is very short, and when life is very short, you know what I'm doing, Mabunda, right now is just to give you a review, because I gave you this as a homework. Mabunda.
Namito Nkwala Nkona.
Yes. Then I gave you as a homework. That's why I'm trying by all means here to be fast here. To be fast, because I'm just giving you a highlight, because the example that we did last time, it was not giving us what I want us to do today. Then that's why I took that homework to say, let's do that homework, because already you have answers for that homework. Now, I will be very, very slow. Now, we said B or blocks, we said they are what? Employee. And we said treatment are what we call assembly method. Now, there is what we call the response variable, which is assembly time. That is the one that we have here. This values. 5.4, and so forth. These values are the mean assembly times. Do you understand, Mabunda?
Yes, I understand.
Now we come to what we're supposed to do today. Now let's do that that exercise. First of all, for you to do ANOVA, you must have the sources of variation, which is the treatment, which here the treatment is assembly method, followed by a block where it's employee, then you are having the error and the total. Now here you are having the SS sum of squares. That is what I want you to find. Find the SS total, find the SS treatment, find the SS blocks, and the last one, SSE. Now, let's start. Let's start, ladies and gentlemen. Let's find the SS total from here. Remember, the employees are blocks. Employees are blocks. And the methods are a treatment. Remember, methods are treatment, then employee are blocks. Now, what will be the sum of squares of total? You must let me know if I'm fast. Let's find the sum of squares of total. Ladies and gentlemen, are you calculating? Sum of squares of total. Where is that? Sum of squares of, do you get 17.79733? Ladies and gentlemen, do you get that? Okay, Mary, Mumba, Natasha, Mumba, yes. Then, do you agree with Natasha? Do you agree with Mary? Do you agree with Kulofel? Okay. Then, remember this example you did as a homework. I just want to show you something. You did as a homework. Now, what is SS treatment? The answer for SS treatment? SS treatment? $5.425. Okay. What is block? Do you agree with Samuel? No, Samuel. Portia? Do you agree with Portia? Guys, where are you? Correct. Then what is block? The answer for block? the answer for block? What is the answer for block? You must tell me if I'm fast. Ladies and gentlemen, are you winning? Ladies and gentlemen, are you winning? What will be the block? What will be employees? SS of employees, sum of squares of employees. Mary, Natash, Siobong, Siobong. Give me the answer. Are you there, ladies and gentlemen? Blessing, yes, blessing. Blessing, give me the answer. I want the answer for SS block. Blessing.
I don't have.
Baba. Baba. Natash. Ah. Guys, did you do this homework? Okay, I got 10.691. Okay. What will be the error? Mabuda, what will be the error? How do we calculate SS block? The SS block is the sum of B. Then here we are having 1 divided by the treatment. You remember? Then we are having the Y, the dot, the J squared minus 1 over N Y dot squared.
Sir, so for the
Yes.
error, can we minus the SS treatment and the SS block from the total and then we get the error? Can we do that?
Amen. Yes. Ladies and gentlemen, amen means let it be so. Amen means let it be so. Muketwa, are you answered? Muketwa? Okay. Now give me the answer. Muketwa, give me the answer for SS error. 1.681 I was told. Then what will be, okay, what will be the degrees of freedom? What will be the degrees of freedom for the treatment? What will be the degrees of freedom for the treatment? That means how many treatment do we have? -1. How many treatment do we have? -1. How many assembly methods do we have? There are how many assembly methods? -1. That is 2. 2, or someone gave me 2, 4, 8. Okay, and 14. Okay. No, thank you very much. Do you agree with Veronica? Sakan. Aye. Do you agree with Sakan? Yes. Okay. Kulufelo?
Sir,
Yes.
I don't know if my calculations were wrong or something. So, but for SS blocks,
Yes.
I got a different answer.
You
Like
got how much?
it's like I got 5.42. The one they got for SS treatment is my SS block.
Oh yeah, yes, I understand. I understand why. Now let's go up a little bit. Okay, let me come here. Now the problem was here. Then what you did, you took employees as treatment. Do you see?
Employees
That
as
means your answer was here. You took this as a treatment, this as a treatment, this as a treatment,
which ones?
this as a treatment, this as a treatment. While this example, our employees, the same way with students, is our experimental unit. And under experimental unit, we have blocks. That means this is block. Employee is block. That means this is a block. Block.
Oh, okay. Yeah,
Block.
I see.
Yes.
Yeah, okay.
Okay. Thank you very much. Thank you very much. Now, let's continue. What is the MS? You can give me all MS. Where is Takani? Tagi. Give me those numbers. Takani, the MS. Vero, give me the answers. The first one is 2.7. 2.71. 2.71, the second one. No. Is it 2.71, the second one? Who's talking now? Let me see. Manya! Manya, where were you? Where were you on Friday?
On Friday, I was around and I was preparing for the test, but attending.
Oh,
Sir,
Manya, man. Yes.
I want to ask, since someone did, I would say it's a mistake, but the person was not seeing that he was doing a mistake. But if it
That's
was
true.
in a test, uh, were you going to penalize the student from swapping the two, the block and the treatment?
Yes. Yes. That's true. I'm going to penalize the person. Or let me say, we are going to penalize the person. We are going to penalize the person. Manya. Now,
Sir,
give me the F values, the F ratio. What is the F ratio for the first one? Where is Kaki? Sagi, give me the answers. What is the answer for the first one? The F ratio. Is 12.9. The second one, the second one, 12.7. Now, yes, 12.7. Now, when you are done doing the ANOVA, now you have to test. Remember the fixed effect model, whereby the first one you test whether the means are the same. Means are the same. The treatment means are the same. How many treatment do we have? We have 3. The treatment means are the same. Opposite says at least 1. is different. Now, this is the first that you must test, where the test statistic we are given 0.05, where the test statistic is F is equals to MS treatment divided by MSE. What will be the answer when we are testing the model? What will be the answer, ladies and gentlemen? And what will be the conclusion? Here is 12.9. Then we have to compare it with the critical value. What is the critical value, ladies and gentlemen? Here is 2 and 8. Ladies and gentlemen, four 0.46. Do you agree with them? Now let's check it. Now we are having 2 as denominator and 8. That means our answer is 4.46. Do you all agree, ladies and gentlemen?
Yes.
Do you all see it?
Yeah.
Any question, ladies and gentlemen? Then what is the conclusion? What can you say? What can you say?
We reject the null hypothesis.
Yes, and conclusion. We reject AH naught, then we reject the H naught.
At least one of the methods differ.
Yeah, that means the mean of the treatments, they differ. The mean of the treatment, at least one of the means, the mean of the treatment differ. Now I want you to, let's go to the second one. Let's go to the second one. Under the fixed model, then we test the blocks. Block 1, block 2, block 3, block 4, block 5 are the same. We are saying at least one. Now, can you please tell me the conclusion, ladies and gentlemen, under blocks? Under blocks. You must tell me if I'm fast. You must say, no, you're involved. Ladies and gentlemen, are you still there? Remember, the F ratio or the test statistic, you get it from here, from the ANOVA. From the ANOVA. From the ANOVA. This one you get it from ANOVA, which is 12.7. Then what is the critical value? What will be the critical value? 3.84. Do you agree with them? Do you agree with them? Then this is 4 and this is 8.
Sir, since we're still on these things of critical values, I need clarity on these formulas.
Yes.
Because like each thing by the sign, like I need clarity on how they differ. We have that one where we have 2 and 8, and then this one is 4 and 8. So I just need clarity now.
Oh yes, yes, yes. Now let me write this test statistic. Your F in test statistic, let's say under treatment now, is going to be MST divided by MSE. Do you see it?
Yes.
Yes, this is the test statistic. It means even when you are going to do the critical, value, it will be the treatment divided by what? Divided by the error. It means your numerator will be the degrees of freedom for treatment. Then denominator will be the degrees of freedom of what? Of error. Do you see it?
Yes, I see now.
Then it will be F numerator and denominator, and your denominator is what? Is error. Then your error, the degrees of freedom for error is 8. For the degrees of freedom of treatment is 2. Then of 0.05. Then you check numerator. The numerators are here. Do you see?
Yes.
Then the denominator is this side. Do you see it?
Yes, I see, sir.
Then if you want 2 numerator, 8 denominator, it means it's 2 numerator, 8 denominator. Then you check the intersect. Where they intersect is 2 numerator, then 8 denominator. Then for treatment, the critical value would be 4.46. Do you see it?
Yes, sir, I see.
Now, can you find the second one? Mabunda, can you find the second one, the critical value for the second one, for the blocks? And give me the answer. The critical value for the blocks. Are you winning?
Yes, can you, okay, yeah, because like I want this table. So we are gonna go to 4 and then we go to 8. So kutakure 3.84.
Oh yes, you are right. 4 and 8. That is going to be, you said 3.84.
Yes, 3.84.
Yes. Do you all understand, ladies and gentlemen, how we got the critical value? Okay. Then, what can you say about blocks?
We also reject the null hypothesis.
Yes, we reject the null hypothesis, and we are saying that there is an effect of the fact. The factor block has an effect in assembly time. In assembly time. Now, remember this year, since we rejected everything, Now, this is what I want us to do. Since we rejected everything, everything. Now, random effect, you must do the random effect. Now, let's come here. Then, if we choose to use the least square difference method for making comparison. Okay, let me do this.
So to say, what was the conclusion for the blog?
Yes, I'm asking you, what is the conclusion? What is the conclusion? This is the block. We may also be interested in testing whether it was advantageous to include the block. Do you think it was advantageous to include the block? Was the block effective?
Yes, SI.
That means we conclude that the block was what? Effective, isn't it? Do you see it? Ladies and gentlemen?
Yes, sir.
Yes. Now, now let's come here. This comparison, yeah, somebody last week was posing a question to say, are we doing comparison for the treatments only? Yes, we are doing the comparison for the treatment only in this chapter. In this chapter. Even last time, when we were doing with Mr. Maluleka, it's only treatment. And we do the comparison for treatments only if another test under the effect model concludes that what some treatments means are different. Did we conclude that the means are different?
Yes.
Yes, yes, yes. Ladies and gentlemen, do you agree? That was our conclusion, isn't it? Yes, yes. Now let's do the comparison. Since we rejected the H naught, then we do the comparison. Now, this is the formula for doing that comparison. The LSD, can you calculate the LSD? Can you calculate the LSD? Can you calculate the LSD?
So, since we are on this one of comparison, are we still having those same names, Double, Duncan, blah blah?
I want to say something after we manage to calculate this.
Oh, okay.
Yes, I wanted to say something. Come here. Then calculate the LSD. Okay. Ladies and gentlemen, are you winning? Are you winning? Ladies and gentlemen, what is the answer? People are quiet. What is happening? Anybody there? The T, remember T, treatment, blocks, fine. Then that is 2 times 4, 8. 0.025, 8. Then this is 2. SSE is 0.21, I was told, divided by blocks 5. Now, what is the answer, ladies and gentlemen? What is the answer? What is the answer, ladies and gentlemen?
The tabulated value is 2.306.
2 point. I mean,
306.
the answer for this. The answer for that.
0.66.
0.668. Do you all get that? Do you all get
Yes,
that?
sir.
Oh yeah. Okay, let's go to now. What can you say? We have LSD 0.668. We have to compare the first treatment, the mean of the first treatment, and the mean of the second treatment. How much is the mean of the first treatment? The mean of the first treatment? The mean of M1 of 4.9. What is the mean of the second one? The mean of the second one? Do you agree with the fortunate? Do you agree with fortunate? Okay, okay.
Yes. Yeah.
Yes. Then is this greater than LSD? Is this greater than the LSD? Okay, but they say 9 point. Is this greater than the LSD?
Yes.
Yes. Then what is your conclusion? What is your conclusion?
Two means are significantly
Means are
different.
significantly different.
Yes, that means the means are significantly different. That means mean 1 and mean 2 are declared significantly different. They are different. Okay, let's go to the second one. Let's go to the mean of the first minus the mean of the third treatment. Ladies and gentlemen, what do you think here? Manyam. What is Manyam? Manyama.
Yes, sir.
Oh, okay, okay. Then, what do you think here? What is the mean? You said this one is 0.4. Sorry, you said this one is 49. Minus, what will be the mean of the third one of the treatment? 3.44. Then, what do you think the same? The means are the same. Okay, the means are the same. Okay. Then, what is the answer here?
The answer
3.9 minus 3.
is 1.46.
1.46. Then is 1.46 is 1.46 greater than 0.668?
Yes.
That means what is your conclusion then?
The two means are declared to be different.
Yes, that means the mean of the treatment 1 and the mean of the treatment 3 are different. Now let's go to the last one. Of 2 and of 3. Now what is the mean of 2? This is 4 minus 3.44. Then what is the answer?
0.56.
0.56. What do you think? Is this greater than 0.668?
No,
What is the conclusion then?
the two means are declared to be significantly the same.
Yeah. Who's talking? Easy. Madam. Yes. Thank you very much. Now, this is what I wanted to do with you today. Is that 10 minutes break? Or should I continue?
You can give us just 5 minutes just for us to go
Yeah.
through.
Yeah,
Ten.
let's come back at 10
Ten.
past 2. Let's come back at 10 past 2. 10 past 2. Let's come back at 10 past 2. Thank you very much.
Sir,
Yes?
when we read the null hypothesis, is it necessary to say mean 1 equals to mean 2, mean 3, and equals to 0?
No. I think all of it, when we are saying is equals to, let me go back. Let me just go back. Like this one. Do you see it says beta? Okay. This one. Do you see? We are
Yes.
just saying all these things are equal. All these things are just equal. They are equals to 0. It means when we are saying these are equals to 0, it means there's no difference, isn't it?
Okay.
Yeah, it's just to say no difference. It means whether you include the treatments or you don't include the treatments, the experiment that you are doing, there's no difference. But if
So,
you find it, then that is good.
so if I don't write equals to 0, is it still fine?
I'm going to mark you 0, not.
No, if I don't write equals to 0, all of them.
You must write, because somewhere here, unless otherwise you write it like this. You see, at least one of the means are different. They differ.
Right.
That will be safe. Ladies and gentlemen, really,
Sir,
yes.
I think what he was asking is, I get this, the first one is model 1, right?
Yeah, that's true.
He was asking that if he can write his null hypothesis as mu1 equals to mu2 equals to mu3 until the number of the treatment. And the H1, he will write that at least one of the means differ. Will you mark him wrong now?
No, I won't mark him wrong.
Okay.
But I'm hearing myself there. What is happening? I'm on speaker. Really? Let me go. Let's come back 10 past
Yeah, I think we can continue, sir.
Yeah. Let's continue. Let's continue. Now, okay, we're here. Now we come to another part called the microphone is fine. The block treatment and interaction. When the difference in the treatment means it's not the same for different blocks, it means we've got our treatment means to be not the same as the previous example we did. The means were not the same. That means the model is no longer additive. Let me explain this. Now, when you look at that model, that model was like this. It's equals to the mean plus the treatment plus the block, plus the block plus the error. Now, this is an additive model. All this, even if here, look at here. Now, we have realized that since the treatments are not the same, the model that we have is no longer additive. We say that the two factors, which is the treatment and the blocks, interact. That means somewhere, somehow, the mean, the blocks, let me do this, the blocks and the treatment, they intersect somewhere, somehow. Now, this is whenever you are having no interaction. This is the treatment. This is the treatment under groups. This is treatment 1, treatment A, treatment B, treatment C. The same here. Now, these are the block 1, block 2, and block 3. And this is the Y, where Y is the response of the mean. The same one as we did, as it said, the mean of the assembly method. This is the same. This is the one. Now, this is A, this is B, this is C. Now, if there is no interaction, that means, what do we mean when we are saying there is no interaction? That means there is nowhere where the blocks and the treatment, they interact. Nowhere. When you look at this, nowhere. Blocks and treatment, nowhere. But whenever you look at where there is an interaction, where is present, that means somewhere you can see that the green and the red, somewhere they intersect. The red and the blue, they intersect. The green and the red, they intersect, and the green and the blue, they intersect. This is what we call the intersection. The intersection. That means we want to see, why do we introduce the intersection? Because our let me go back. Our treatment means it's not the same. That means there might be an intersection of means. There might be an intersection of the treatment and the block, as we have seen from the graph. The presence of block by treatment. Now, I want you to look at this statement. This statement will always help you in identifying which one is the treatment and which one is the mean. Look at this. Beautiful. The presence of block by treatment. Block by treatment. That means the block comes here by treatment. Interaction effects tends to inflate, meaning to reduce what we call the errors. That is what we want to do in statistics. We try to reduce the errors. This. Now, by doing what? We are trying to reduce this by doing what? By adding what we call the interaction. Now, the formula is going to be given by this. Beta J, then you have I, you have treatment this. We include this one in the model. Plus the intersection, the multiplication of the two. Because there might be an intersection. You did intersection in first year where you are saying joint, intersect. We call multiplication.
Sir,
That's why here we call it.
before you move on, I want to understand something.
Yes.
So I want to understand if when the treatment means are not the same or different, is when the blocks are intersecting.
We assume that that is what we assume right now. We assume that there might be an intersection, because we have rejected that there might be an intersection. Like before. Oh, good. Let me do something like this. CRD, whenever you rejected the treatment, you said there might be another factor that might contribute towards that, and you call it block. After rejecting the treatment again, you are saying there might be another factor which is called the interaction. Why do we do this? To reduce the errors. Do you see how this step by step? We are just doing step by step to arrive where we reduce the errors. Who was talking? Cool fellow? It was you?
Yes.
Oh, okay. But do you understand
Yeah,
what I
I
was
understand
explaining?
now. Yeah, I
Yeah,
understand.
step by step. We started here CRD, this one, RBD. Then under RBD, there is what we call the interaction. Then let's continue. Now, that is to do what? The experimental errors. Do you see? Yes. Again, I want you to look at this. Block by treatment. Block by treatment. To account for variation in the responses, which is the Y's, that is due to block by treatment interaction. We can replicate, and you know replicate, the term replicate, isn't it? Is the same as repeat, isn't it? Repeat. I'll explain that. Let's go to, let me explain this. Now, you did this under the CRD, whereby there was what we call the replication, where under one treatment, you were doing repetition. Under one treatment, you were doing repetition. You remember this?
So,
Yes. You remember this?
yes, we remember, sir.
Oh, yes. Then, even in our RBD, we have what we call replication. What do we mean? Under the CRB is when we concentrate on block. This one was only on what? On treatment. This one was only on treatment, doing repetition on treatment. But this one, the one that we have, is based on, we are doing repetition in a block. Repetition in the block. Do you see it? I maximized it. Do you see it? Repetition in the block. Now, let me explain this. Now, you have repetition, many numbers. That means can be 1, 2, until R. Now, you have to find the mean of that block 1. Sorry, the total of that block 1, and also the mean of that block 1. What I want to show you is this one. I want to correct this one. This one should be 1, 2 dot. 1, 2 dot. Should be 1, 1. This one on number 2 is to be 1, 2 dot. Then Y bar 1, 2 dot. Do you see it, ladies and gentlemen?
Yes.
Not 1, 1. And this one, I just want to rectify that. Should be, you can also rectify it in your study guide. It should be 1, 2 dot. That means is the total of that block and the mean of that block, which is block 2, treatment number 1 here. Now, the same, you know how to do the Y1 dot dot. Now, if you look at this, the total, it says Y dot dot dot. Do you see it? There are 3 dots. It means it's the treatment, the blocks, and what? And the interaction. Ladies and gentlemen, you remember RCBG? You were only having Y dot, isn't it? It was only for treatment. You agree? Then we come to, sorry, we come to CBD. We have Y dot dot. Sorry, let me do this. Somebody. Oh, Raymond. removed. Now, under RCBD, we're having this. This means it was YI. This one is I and J. We have the interaction where we are having Y dot dot dot, where we are having I, J, and what? And K, where this K is an interaction. Different books, okay, let me do this. Different books, they will use different naming. Interaction. Do you understand, ladies and gentlemen? Do you get it? Yes. Now, let's do this. I want you to do this. Look at this. Look at this. Look at this. Let me do this. Let me stop the screen. Let me share the document. Let me share the document. While I'm still loading the document, I have a few announcements. One, after class tomorrow, please collect the scripts. After the class tomorrow, 11 class tomorrow, it's time for you to collect the scripts, test scripts. Any question? Tomorrow, after 11 class, please collect the script. Yes, quiz 2. Yes, I will tell you about quiz 2. Now, this is the I will tell you about the quiz. This is the exercise example. I will address it on Friday. For those who missed the test, we'll address it on Friday. Friday, it will be a feedback class, and also for those who did not write the test. Those are announcements. Yes, Friday. Come on Friday. Pass rate not yet. We are not done marking. Yeah, but tomorrow will be done, even capturing the marks. Then now we are here. We are here. Now, remember what I've told you. Do the data suggest the presence of operator by filter? What do you think here is the treatment? What do you think here is the treatment? Which one is the treatment?
Filter.
Look at this. When I was explaining this, I said there are certain ways we shall hear. It says it accounts for the variation in the responses that is due to block by treatment interaction. Then what do you think, ladies and gentlemen? The presence of block by treatment effects, interaction effects. What do you think is a block? What do you think is a treatment? From this, do the data suggest the presence of operator by filter interaction?
Filter, it's a treatment, so then operator, it's a block.
Oh, yes, yes, yes. Oh, manyam, yes. Now, remember this, because here we are having repetition, which is 2, which is 7.6 and 8.8. Also in the second one. Yes, Baba Marulega.
What did you say is the block and treatment?
What is what?
The block and treatment.
I'm asking you from the statement which I gave you here.
Okay,
Look
shouldn't
at this one. Look at this one. The presence of block by treatment interaction effects tends to inflate the estimate of the experimental error, and this has an effect of making the test of comparing the treatment means insensitive to the treatment difference. To account for variation in the responses that is due to the block by treatment interaction, we can replicate the basic RBD. What do you think there is a treatment?
I see that, but then the guy who just answered now, didn't he say the opposite or something?
The guy, what the guy said, what do you think? You tell me, what is the treatment?
Can you go back to the question? I can't remember.
Okay.
I think
Okay. Yes. Do
shouldn't
the
the
data
block,
suggest the presence of operator by filter interaction?
okay, shouldn't the block be the operator,
Treatment
the filter?
and block. You are saying what?
Isn't the block the
Operator.
operator?
Okay. No, I want to write what you are saying. Block operator and filter treatment. What did Manyama say? Manyama, where are you?
I said the way he's seeing things, but I don't know. I don't know how he had me.
Yes, Manyama said the treatment is the filter, the block is on the operator.
Oh, I thought I heard the reverse. I'm sorry.
Oh, yes, yes. Then it's fine, it's fine. You are a human being. Now,
Say,
we'll do this example tomorrow.
say,
Yes.
go back to that slide again. Okay, okay, thank you.
Okay. Now, this example, please, you must do it at home and calculate. Now, I want us to find the total for block 1, treatment 1, and also the mean for each. We must find the total for each block and the mean of each block. Now, let's go. What will be the mean here? What will be the mean and the total for the first one? 1, 1. What will be the mean here and the total? The mean and the total?
The total
Remember
is
what we are doing.
16.4.
16.4 is total. The mean?
8.2.
8.2. Now, this is what we are doing. People will say, what are you doing now? This is what we are doing. We are trying to find the total in each and every block and also the mean in each and every block. That is what we did on the first one. We can do the second one and the third and the fourth and so forth. You can do it at home. We'll do this exercise tomorrow. Today, I just want to deal with the theory. Now, this is what I was explaining to say there is an interaction. And whenever there is an interaction is when we are including another variable called the treatment and the block, because there is where they interact, where they interact, where they interact. Multiplication. Obvious.
So
Whenever, yes.
since we are still on this one year interaction, so how are we gonna know there's this thing, like are we gonna be told on the information, or maybe we're gonna see it with a diagram? I mean, like, how are we gonna know?
Yeah, yes. The one thing is that you will be told that you must calculate. But let me do something. It's there. I know it's there on your notes. Let me go. I will maybe if I don't arrive there, that means it's tomorrow. But I will answer you today, isn't it? If it's not here on the slides, that means I will answer you today. But the answer you'll find, you'll see it, but today you won't see it if it's not here. Now, this is the total. Now the total. This is the total. Is IJK. This is what I was explaining last time, to say this is IJ and K, whereby you're having the treatment, the block, and also R means the replication. How many are there in the block? Replication. How many are there in the block? That is a replication. And most of the times you want to check the interaction if there are replication in the block. Now these are the formulas which I'm projecting now. Please make sure that you check these formulas, and tomorrow we are going to do that example using this formulas. That example of filters. Now, the model from this, you are having this called model, and this model is given by this. This can be SST, SSB, and SS interaction. Interaction means where they intersect. These are the formulas. Practice them tonight, and make sure that you're familiar with these formulas before tomorrow, 11:10. Now, this is the ANOVA. The end of the matter before we can test is this. You find the ANOVA before we do what we call the fixed effects models. Then this is this. Now, these are just the main these are just, then this is the hypothesis under the block. We are saying all the interaction. Yeah, the questions. This now is just theory. I'm just giving you the theory behind. Then this is all the interactions is equals to 0, the same way as it was the treatment, you remember, and the blocks, you remember. Now we come to the interaction. We are saying all is equals to 0, where at least one is different. Now, this is the test statistic. Please practice this. Look at them.
Sir,
yes.
What is that simplifying?
What is
The T on the test statistic?
This one. Oh yeah. Okay. Sorry. The T on the test statistic. I hope it's there. Is this one? Do you see? Is the sum of the block times the treatment, the interaction. the interaction between the treatment and the block.
Okay, so
Follow?
it's treatments.
Yeah, treatments.
Okay.
But this one, don't just say it's treatment, you multiply treatment, SST and SSB. No, it's the interaction. Is the interaction of the two.
Okay.
Sorry, Kolo. Then that is that. Yes, somewhere they'll just write it like this. Somewhere they'll just write it like this. Kolo, do you see?
Oh yeah, it's the same thing. Yeah, I can see.
Yes, yes.
Okay.
Now, here, yeah. Now, this is the main effect. Now, blessing, I think the answer is here. Blessing,
Yes, I'm here, sir.
the answer is here. The answer is here. If we reject the null hypothesis about the interaction, what do we mean? If we reject this, sorry, if we fail to reject this, if we fail to reject this, if we fail to reject the null hypothesis about the interaction effect, we test the main effect. You know the main effect, isn't it? Which are treatment or block effect. Meaning we are going to do the what is happening now? If we fail to reject the null hypothesis about the interaction, this is what we mean. If we fail to reject this, that means we are going with this one. Now, if we are going, please don't communicate in our chat room, please. If we fail to reject the null hypothesis about the interaction effect, we test the main effects. Now, what are the main effects? Which are the treatment and the block? Main effects under both models, that is the fixed and the random effect. If we fail to reject this, if we fail to reject the interaction, then what should you do? You go back and test what? And test this. You go back, 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 and do what? And test this, yes. And test this. And test the treatment. If we fail to reject the interaction, then that means there is no interaction. And if there is no interaction, you go and test this model. You go and test the mean, you test the blocks, and also you come here, you test the random effect of the variance and all the block effects. You do that. You do that.
So,
Yes.
like on these things, marketing and those seem to be a long procedure.
Yes, it's a long procedure. Yes, I agree with you. I agree with you, 100%. But remember, blessing, whenever you're going to work, let's say you're working, you're at the you're working maybe for the hospital, Mangway. You don't need to. I will come to you, Kulufelo. You don't need to go and calculate the treatment and the blocks. You can only test the interaction. If the interaction is not there, then you can you can, if the interaction is not there, then you can go back and test the treatment and the blocks. But if it's there, there's no need. That means that gives you that there is interaction. Gives you that there is an interaction. Isn't it? We are trying to reduce one by bit by bit. There's no need to use the CRB. There's no need to use the RBD. You can use the interaction RBD. Do you see, Blessing?
Yes.
Simanga. Let me ask Simanga. Wait a bit. Just give me 1 minute. There was a question that I said I will come back to it. Then are we going to be given formulas? Kolofelo, Augustine, no. As Portia, you are saying is SS model equals to total? No, they're not the same. They're not the same. Under model, let me show you. Under model, this is total. Do you see it? Then this is the mod. What is the model? Then this is the model. The model is having SST and this one and that one. It does not have SS error. It does not have SS error. That's why if you want to find the intersection, you must say model minus the treatment minus that. This is the total. The total is having everything. That's why when you want to find the total, you are saying the error plus 1, plus 1, plus 1, plus 1. Error plus treatment plus block plus interaction, you get the total. To answer you, Portia. Any question, ladies and gentlemen, before I take the comparison? Any question, ladies and gentlemen, before the comparison?
Sir,
Yes.
even in the exam, we are not giving us this formula sheet.
Yeah, the issue is that you are a mathematician. You are only dealing with formulas. Why then do you need formula sheet? Maya.
We are not doing one module. Sir. The formula sheet is for a student not to cram this thing, but to understand the procedure and understand which formula to pick and use. But when we tend to learn and at the same time we are forced to grab these long formulas which we are not even going to use, some of us, because we are in different departments. So it's difficult to say.
Yes, Mayama, let me tell you, if you know these formulas, isn't it they are helping you to calculate? Let's say
The
in the
process
future you won't use the calculation. You'll be using the machine, isn't it? You'll be
is will
using
be
the
using the
machine.
machine. Yes.
Yes. But let's say, for example, you are not sure about that. Maybe you have done something wrong. You have to punch the calculator and see whether you are doing the right thing or not.
Sir, you see, even when you mark our test and what, you can clearly see that some of the students, they forget on F, they swap the degrees of freedom because they are in a hurry because of what? They are not seeing these formulas. They are trying to remember them. The problem is memorization. How do you always remember these formulas? It's simple to do these things,
Yes.
but how do you remember every time? Because sometimes you can know all these formulas, but you meet an incident that can confuse your mind not to remember some of the things, and you fail a test knowing these things, but you forgot a mere one thing, and you fail. Statistics, if you fail the ANOVA, you fail absolute.
You are right. You are right. There I agree with you. I agree with you 100%, Maya. To say if you miss the ANOVA, that means you are out. I agree with you. And that's why, by all means, that's why we call it education. You learn ways of memorizing those formulas, knowing those formulas, remembering them. You may not use them, but you must know them. You may not use them, but you must know them. You see, that is what I'm saying. Then somebody was asking, yes.
The thing is that on the previous question papers, I see they were giving mathematicians formulas.
You mean which formulas?
The mathematicians which came before us, they were given these formula sheets before. I don't know if things changed.
Yeah, I think things changed. Things changed, but things can also change again, isn't it? It's just the way. I think the issue of, I don't know why did they not give them or give them, but for us to give to because these formulas to us, they're not different. It's just to include I and J and K. But I understand what you are talking about. We're talking about cramming, isn't it? Because somebody says remembering the formulas during the test or the exam. You see, is that say it's not like we don't know these things. Problem is remembering the formulas during the test. Yes, I agree. I agree with you. I agree with you. But we'll sit down and see what we can do. Because formulas, some people in the future, Manyama, isn't it? They will say, you must give us another table. You see? Manyama?
I understand the ANOVA. On the ANOVA, I understand, but
Yeah.
formulas. Say, do you like
Yes.
you see, like a person can know how to do it to construct completing square, like a mathematician still at high school can do this procedure, but you find this thing, you know the procedure to find the completing square to arrive at quadratic for a safety when you practice when you are on your spare time, but when you write a test you may there are some things which happen during the test, and even now as I am old like a mathematician now, I'm fully, I can't know if why do we do these simple mistakes when it comes to the formulas we know. After the
Yeah.
exam or test, you see, ish, I did a silly mistake on that formula. I was supposed to use the degrees of freedom -1. I used it just treatment, or I used -1 on treatment. You see, say.
Yes. I think I agree with you, Manyama. There, I agree with you. That's why I said we will see what to do, isn't it? We will see what to do. I was just giving you to say. Some will say, give us the another table. You see now that is, but that I understand you. I understand you. Isn't it when you talk, I'm also questioning myself with other things, isn't it? Yes. But thank you very much. We'll address that very soon. We'll address that very soon. Then the quiz. Somebody was asking about the quiz. The quiz next week, Friday, there will be a quiz on chapter 3. There will be a quiz on chapter 3. There will be a quiz on chapter 3. Thank you very much. Friday, next week, after 7, there is a quiz. Thank you very much. Have a nice day.